Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the minimum area to cover all ones part 2. We have already solved the part 1 of this problem yesterday. It was problem number 3195. Today we are going to solve problem number 3197. This is of hard category and we are going to solve it in such a way that you are going to find it little comfortable, little easy to solve. The time complexity at which we are going to solve this is O of m square multiplied by n square, where m is the number of rows, n is the number of columns, and the space complexity we are going to solve it is going to be constant O of 1. Now we are given a two-dimensional matrix or an array. That's our input. This 2D matrix or array contains either 1 or 0, or either 0 or 1. Now the output we need to give, first of all we need to find the number of non-overlapping rectangles having non-zero areas, with all these rectangles covering all the one in the original grid. Now this might sound confusing, but it is actually easy to understand. We are given a 2D matrix, right? A 2D matrix looks something like this. A rectangle, right? It has rows, it has columns. So this is our 2D matrix. So once we have a two-dimensional matrix given with us, we need to find three non-overlapping rectangles. For example, this is 1, this is 2, and let us say this is 3. These rectangles should have non-zero areas. So basically your rectangle should exist. You cannot just create two rectangles and say that the third rectangle is there but the width and height are 0. You should ensure that they should have non-zero areas. And these rectangles should cover all the one in the original grid, or basically in the original 2D matrix or the 2D array. We are given a 2D array or 2D matrix, right? We need to ensure that these rectangles are covering all the different ones which are present in my 2D matrix. Now once you are able to find these three rectangles which can cover all the ones, we need to return the minimal possible area of these rectangles. Basically we need to return the area of these rectangles. If we have three rectangles, we have to return the area of the sum of these three rectangles. But we need to ensure that we return the minimal possible area of these rectangles. So basically these rectangles has to be as minimum as possible in size and area, but still it should cover all the one in the original given 2D matrix. Now let's try to understand it with an example. Let us say this is our 2D matrix or 2D array which is given to us. It has 1 and 2, two number of rows, and 1, 2, 3, 4, four number of columns. Now the part 1 of this problem was all about finding a rectangle or finding a submatrix with the smallest area which covers all one. But now we need to find three such rectangles which should cover all ones. We cannot just create one rectangle and say that it is covering all the one. So this is our final rectangle. We have to divide this particular 2D matrix into three different rectangles which is covering all the one, and the sum of the area of these rectangles should be as minimal as possible, as less as possible. That is what we need to return. So imagine this. This is my original rectangle, right? It has 1, 2, 3, 4. 4 width, 1, 2. 2 as the height. So the area is 4 multiplied by 2, which is 8. This is the area of my original matrix. Now I want to find three rectangles. I want to divide this 2D matrix into three rectangles which can cover all the ones. So let me actually divide this. I can say this is my first rectangle, this is my second rectangle, and this is my third rectangle. Basically this area is the first one, this area is the second one, and this area is the third one. This is one of the possible answer. Rectangle 1, rectangle number 2, and rectangle number 3. Now the question says that the three rectangles should be non-overlapping. I cannot create this rectangle as 1 and this rectangle as 2. They are overlapping here, right? They should be non-overlapping. They can share the border, but they cannot overlap with each other. Now notice here, these three rectangles are covering all the ones we are having in the original grid, right? So this is valid rectangles we have created. Now let us try to find out the sum of the area of these rectangles which we need to return. So for the first rectangle, we have 1, 2. The width is 2. The height is 1, right? 2 multiplied by 1 is equal to 2. The area of the first rectangle is 2. Similarly, the area of the second rectangle is 2. And the area of the third rectangle is 4. So we are going to return 4 plus 2 plus 2, which is 8. But remember that we have to return the minimal possible area of these rectangles. Now I want you guys to understand that this is the part 2 of the problem. Find the minimum area to cover all ones. There's a strong reason it is the part 2. It is highly related to the part 1 of this problem. Now right now I have converted my one rectangle, one 2D matrix into three sub matrix, right? This is 1, this is 2, and this is 3. Do you see another problem here? Right now we have got the area is 8. We need to return 8, but we can minimize the area, minimize the possible area of these rectangles. Do you see any other problem here? Yes, we have it. If we talk about this particular rectangle, rectangle number 1, it is covering this one, right? The rectangle number 2 is covering this one, and the rectangle number 3 is covering this and this one, right? I have a sub problem here. The problem is, in each of the rectangles which we have created, find what is the minimum area which can cover all one. Try to think about it. Let's forget about rectangle number 2, rectangle number 3. Just rectangle number 1. If I talk about this rectangle, it is covering just one number of 1, right? And I am saying that the area is 2 is the width, 1 is the height, which is 2. But instead of that, if I treat this as a sub problem that, hey, if this is my rectangle number 1, find what is the minimum area which can cover all ones. Basically, within this rectangle, I can say that this is another rectangle which can cover all the one, right? I don't even need to count the area as 2 because this is the rectangle which is covering this one. Then why should I have this particular part as the rectangle number 1? I could simply say that initially I thought this is my rectangle number 1. Within the rectangle number 1, I can simply find the minimum area which can cover all ones. So it is just this rectangle, right? The area is not 2, the area of the rectangle was 2, but this can be converted to an area of 1, right? Basically, this particular rectangle is having width as 1, height as 1, area is 1. Similarly, in the second rectangle also, we can have the same sub problem. We can say that, alright, I got a second rectangle, but what's the minimum area which can cover all ones? It's actually just this rectangle, right? It can cover all the one. Similarly, in the third rectangle, I can say that this is my rectangle which is covering all the ones. This is the one, right? Now, if I take the sum of these three rectangles which I got, you will see that the sum is reduced. The area of the first rectangle is 1, second rectangle is 1, the third rectangle is having a width of 3, height of 1, so the area is 3 multiplied by 1, which is 3. So 3 plus 1 is 5. I can have a minimal possible area of 5 of these three rectangles, which is going to cover all the ones. So now if I show you the original rectangles, it will be this one, and this one. These are the three rectangles which is going to cover all the ones. So now you understood that we need to divide our original 2D matrix, our original rectangle, into three parts. First, we are going to divide this into three parts, and for those three parts, we are going to find out the minimal areas, which is going to cover all the one, and just take the sum of those areas and return it. Why I am dividing my array originally in three parts, and why I am not directly trying to find out the minimal areas? The reason is we are going to overcomplicate a very simple concept. If we try to find out three different rectangles, I can say this is 1, this is 2, this is 3, right? So here we have to first of all find out, are these three rectangles covering all the ones in our grid or not? So we have these two ones not covered, right? Then we will try with some other combination. This is my rectangle 1, this is 2, and let us say this is 3. Still we are not able to cover 1, all the 1. So we are going to brute force all the different possible number of rectangles which we can cover. But instead of that, if we actually try to divide our original data into three parts, original 2D matrix, 2D rectangle into three parts, then we are sure that those three parts are definitely going to cover all the ones, because we are not excluding any item. When I say that this is my rectangle and I divide it into three parts, part number 1, part number 2, and part number 3, these three parts are definitely going to cover all the ones, because we are not excluding any one here, or any 0 or any 1. We are not excluding any item here, right? For all these three parts, I can just find out what's the minimal area to cover, which can cover all the ones. So that is like utilizing the part 1 of this problem, where we have to find just one rectangle which can cover all the ones having minimum area. So we can apply the same problem in our three different rectangles we are going to create. Now the real question here is, how are you going to divide your array or the 2D matrix? Now before we try to divide our input into three parts, let's have a simple understanding here. The understanding is, when you are given a 2D matrix or a 2D array, it means you are given a rectangular data having rows, having columns, right? This rectangle is going to have a width, which is the number of columns, and a height, which is the number of rows, and it is going to have some area, which is width multiplied by height, right? Now my task here is to divide my data into three parts, right? As of now, I have divided it into four parts: part 1, part 2, part 3, part 4. What's the best way to divide this into three parts? See, the simple thing is, I am given a rectangle, right? I can simply say that let me first divide it vertically. So the moment I am dividing it vertically, I am dividing it into part number 1, part number 2. If I divide this vertically and I want to divide this into three parts, again what I can do is I can divide it vertically. So this is part number 1, part number 2, and part number 3. That is going to be one way of dividing my 2D matrix or rectangle into three parts. And this is the way. If I am given a two-dimensional matrix, I could simply divide it into three parts just by drawing two vertical lines. This is part number 1, part number 2, part number 3. For our given input, what could be that? This is my original data. I could say part number 1, part number 2. This is rectangle 1. this is rectangle number 2, this is rectangle number 3. Now within these three rectangles, we are going to solve a sub problem of finding the smallest rectangle covering all the ones. So this is 1, this is 2, this is 3. Now this is one way, right? There is another way to do it. If I just draw a vertical line and draw another vertical line, this is going to be the way. But if I draw a vertical line and now I draw a horizontal line, then this is part 1, this is part number 2, this is part number 3. Basically, I am talking about this particular way of dividing our rectangle into three parts. Part 1, part 2, part 3. Draw a line in between and then draw a horizontal line in the right hand side. Part 1, 2, 3. Or I could say draw a line in between, but now divide it horizontally in the left. This is part 1, this is part 2, this is part number 3. So we have seen 1, 2, 3. Three combinations of dividing the 2D matrix into three parts. And all these three combinations are first dividing our original data vertically. After dividing it vertically, we could divide vertically once more, or we could say divide vertically, then divide horizontally, or we could say divide vertically and divide horizontally. I can say in my given data, if I divide this vertically, this is part 1, this is part number 2, and now I can divide it horizontally. This is 1, this is 2, this is 3. Or I could say this is my data, divide it vertically and divide it horizontally. This is part 1, part 2, part 3. So these are three different ways to divide our rectangle into three parts. But there are three more ways. Right now we are trying to divide it vertically first. Instead of that, we could divide it horizontally first. After dividing this horizontally, we have three combinations. Now again we can divide it horizontally. So part number 1, part number 2, part number 3. Basically this is our data. Or I could say divide it horizontally and then divide it vertically. Part 1, part 2, part 3. Or I could say divide it horizontally and divide it vertically in the downside. So part 1, part 2, part 3. So it will look something like this. Either divide it horizontally 2 times, 1, 2, 3. Or I could say divide it horizontally and divide it vertically in the upward direction. So it will be 1, 2, 3. Or divide it horizontally and divide it vertically in the downside. So 1, 2, 3. These are the different 6 ways of dividing your rectangle into 3 parts. Now let me show you how can you do this thing with your original data, original input. Let me increase the size of this input. Let me make it 4 by 4. We have 4 number of rows and 4 number of columns. If you are able to divide your rectangle into 3 parts, solving it is going to be easy. The moment you are able to divide it into part 1, part 2, part 3, we can simply say that in each of the 3 parts, try to find out the minimal rectangle which can cover all the ones. That is the possible answer. We are just going to find out all the possible answer and return the minimum possible out of it. So our main task is to divide our data into 3 parts. So let us concentrate on these two ways first. That is divide it vertically or divide it horizontally. So when I say divide it vertically, if this is my original data, I can simply say that this is part 1, this is part 2. That is part 1, part 2, part 3. Or I could say part 1, part 2, part 3, right? 1, 2, 3. And when I say horizontally, it is 1, 2, 3. Or I could say this is 1, this is 2, this is 3, right? Now notice here, when we are dividing it vertically, we are actually choosing all the rows in each of the 3 rectangles, right? We are choosing all the rows. When we are dividing it horizontally, we are choosing all the columns in each of the 3 rectangles. So this is going to be our overall concept. We have 6 different ways to divide our data, right? Now let me take you back to the code editor and let me try to explain you the complete code for this particular problem. And we are going to understand each of the 6 patterns one by one. So let's first concentrate on this particular pattern where we are dividing our rectangle into 3 parts horizontally. So first of all, we are going to calculate the number of rows and the number of columns in our original grid. So it is going to be the length of the grid, which is the number of rows, and the length of the grid of 0 is going to be the number of columns. Now we are having a function def area, which is going to calculate the minimum area of a rectangle which is covering all the ones. Basically, we are going to use this to solve our sub problem. For now, let us not concentrate on this. For now, let us concentrate on dividing our original grid, original data into 3 parts. So first of all, we need to concentrate on the 2 horizontal cuts, right? So this is going to be the code for dividing our rectangle into 3 parts, 3 horizontal parts. We are going to run a loop in the range of rows. That is, for each of the row we are going to run a loop, and inside this we are going to run another loop from the current row to the number of rows. And then our answer will be, basically we are creating an answer variable initially, which is going to be a very large value. We are going to reduce this answer value. We are going to say answer is equal to minimum of current value of answer and the sum of the area of the 3 rectangles. That is area of the rectangle 1 plus area of the rectangle 2 plus area of the rectangle 3. In the rectangle which we are dividing, there are going to be 4 different points. The starting row index, the ending row index, the starting column index and the ending column index. This is going to be defining our rectangle. So when we are dividing it horizontally, we have to cover all the columns, right? So you can see for columns in all the three rectangles, the values are same. It is starting from the column index 0, which is the first column, till all the columns. Basically, the last indexed column will be the number of columns minus 1. So we are covering all the columns from 0 to cols minus 1, from 0 to cols minus 1, from 0 to cols minus 1. Cols is basically the number of columns, right? But for the rows, we are saying that from 0 to I is our first loop and j is our second loop. So we are dividing our array into three parts horizontally by saying that we are covering all the columns, and rows will be from 0 to I, then I plus 1 to j, and then from j plus 1 to the number of rows we have, that is rows minus 1. This is going to divide it into three horizontal parts. But for the three vertical parts, it is just going to be the opposite of what we did. Here we are trying to concentrate on the rows. For the three vertical cuts, we are going to run a loop for the columns. And then again, our answer is going to be the minimum of the current value of answer and the sum of the area of the three rectangles. It is going to be rectangle number 1, rectangle number 2, and the rectangle number 3. Now here you will see that when we are doing a vertical cuts, basically I am talking about this particular pattern. So when we are doing vertical cuts, we have to select all the rows. So you will see that for rows, the starting and ending index are covering all the rows from 0 to rows minus 1, zeros to rows minus 1, zeros to rows minus 1. And for the columns, it is from 0 to I plus 1 to j, and j plus 1 to cols. This is basically going to divide our rectangle into three vertical rectangles. Now, as of now, we have not seen the area function. We are going to see this, but just for the hint, this is completely the part 1 of this problem, where we are trying to find out the minimum area which is covering all the one when you are given a rectangle. Now, let us concentrate on this particular loop, which is covering the other 4 patterns. We have 4 more patterns, right? These are the 4 other patterns we have, right? So we are going to cover these 4 patterns as well. We are going to say for I in the range of rows and for j in the range of columns, we are going to run a simple loop, and we are going to cover each and every point in our grid. And we are going to say answer will be equal to the minimum of current value of answer and the sum of the area of the 3 rectangles, right? Basically, we are having pattern number 1, pattern number 2, pattern number 3, and pattern number 4. We are trying with all the 4 patterns. Ultimately, we are storing the answer in our answer variable, and this is going to be the minimal possible area, right? Now this first line of code, this is for the pattern number 4. The pattern number 4 you can see on the screen. In this, the first rectangle is covering all the columns, and the other 2 rectangles are now covering all the columns. And the first rectangle is going to cover some part of the rows, and the other 2 rectangles are going to cover other part of the rows, right? So the code for this will be, for columns, the first rectangle is going to cover all the columns. The other 2 rectangles are going to cover the remaining part of the column. So it will be from 0 to j and j plus 1 to cols of I minus 1. And for the rows, it will be from 0 to I. That is, the first part of the rows are going to be covered by the first rectangle, and the remaining part of the rows will be covered by the rectangle number 2 and rectangle number 3. So it will be I plus 1 to rows minus 1 and I plus 1 to rows minus 1. Similarly, we are having the 4 logic for the 4 different patterns. Now this second line of the code, this is trying to create the pattern number 3 here. So to create the pattern number 3, we have this particular line of code. This particular line of code is covering the pattern number 1 here. So you can see the pattern number 1, and this particular line of code is for the pattern number 1. And this particular line of code is for the pattern number 2 here. So I would want you guys to go through the different patterns which I have created and go through the code to understand how are these 4 patterns created. I have already given you all the understanding. It's just that you have to just concentrate on the code to understand everything, right? Now let us go through the function area. The area function is very simple. It is having 4 different points, which is telling me the starting row index, ending row index, starting column index, ending column index. Now we are having 4 variables: left x, right x, top y, bottom y. Basically, to calculate the width and to calculate the height. This particular code is all about the part 1 of this code. There is nothing new. So to have the deeper understanding of this particular part of the code, you have to watch the part 1 of this video, which you can find at the I link. These 4 values are trying to create the 4 different points of our rectangle, which is going to cover all the ones having smallest area. We are going to run a loop in our original rectangle having dimensions of a, b, c, d. And then anytime if the grid value here is 1, that is if the grid of ij is equal to 1, we can skip this equal to 1 because 1 will be true. We are trying to find out the minimum value of lx, maximum of rx, minimum of ty, maximum of dy, and then returning the area. Now again, for understanding the complete logic of this code, you will have to refer to the part 1 of this video. But in short, I will tell you that this particular part is trying to find out, given a rectangle, create another rectangle which can have a minimal area but covering all the ones. So this is going to be the complete code for this particular problem. You can find this particular code as the pinned comment of this video. Let me submit this. This is going to pass all the test cases, and this is a pretty good solution for this particular problem. You can see that runtime wise it is fine. Memory wise also it is fine. So we have solved this particular problem in an efficient way. But the thing is, guys, if you want to really understand the complete problem, just make sure that you are understanding the pattern creations, that how are we creating the different patterns, what's the logic behind it. I have tried to explain you everything, but if you have any questions, then make sure that you put it in the comment box. And that's it for this video, guys. If this video helps you to understand the problem, the solution approach, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.